Welcome to one of the most comprehensive Abaqus training package ever created for explosion and blast analysis. If you've been looking for a complete resource to learn advanced blast simulation in Abaqus, you're in the right place. This master class contains 65 hands-on workshops that cover almost every major explosion modeling technique available in Abaqus. Whether you are a graduate student, researcher, university instructor, a structural engineer, mechanical engineer, defense engineer, offshore engineer, or simulation specialist, this package is designed to help you build practical skill that can be applied to both academic research and industrial projects. Unlike many online tutorials that repeat similar examples, every workshop in this package presents a unique engineering problem, different materials, different structure systems, and different blast loading conditions. The goal is not simply to teach Abaqus commands, but to help you understand how to develop reliable, high-quality explosion simulation from start to finish. This the package is organized into four major sections, each focusing on one of the primary explosion analysis methods available in Abaqus. Uh, this the first section is dedicated to the coupled Eulerian Lagrangian or CEL method you can see here. This section contains 22 workshops covering some of the most advanced fluid structure interaction problem in blast engineering. You will learn how to simulate uh, underground um, underground explosion, underwater explosion, contact explosion, internal explosion, sequential explosion, and even large-scale bomb detonation as the nuclear bomb explosion. You can see it here, these two figures here. Uh, the engineering application include underground tunnels, buried pipelines, floating offshore structure, reinforced concrete buildings, steel ultra-performance composite beams and columns, concrete field double skin, steel tabular structure, masonry walls, gravity dams, rock blasting, blast holes, aluminium hulls, reinforced concrete slabs, and protective tunnel system strengths with GFRP. Uh, the CEL method is one of the most powerful approach for modeling blast wave propagation and flow structure interaction, and these workshops will teach you how to build robust and accurate numerical models. As you can see here, we have also couple explosion at the same and with dilation time here. The second section focuses on the smooth particle hydrodynamic or SPH method. SPH is specifically useful for problems involving severe deformation, fragmentation, and large material movement. In this section, you learn how to simulate rocket impact, internal explosion, TNT detonation inside rock, blast loading under reinforced concrete slab and walls, composite columns, masonry structure, aluminium metal foam, sandwich panel, and reinforced concrete columns protected by steel jackets. Uh, You'll also investigate the structural damage using advanced constitutive models such as the concrete damage plasticity, Johnson-Helmquist model, and many other advanced material for foams and metal foams. The third section includes the acoustic method, which is widely used for underwater explosion. You can see here. These workshops demonstrate the interaction between the shock wave and submerged structure using acoustic elements. Application include ship hulls, cylindrical aluminum shell, marine sandwich structure, stiff paneled stainless steel blast panels, and concrete gravity dams subjected to underwater explosion. Uh, this section is particularly valuable for offshore, naval, and marine engineers interested in underwater shock loading and acoustic structure interaction model. The final section focuses on the CONWEP method, one of the most efficient approaches for air blasting loading in Abaqus. This section contains 27 practical workshops covering blast resistant structure and advanced composite systems. You will simulate reinforced concrete beams and columns, ultra-performance slab, ultra-performance fiber reinforced steel composite beam, aluminum sandwich structure, glazed composite panels, CFRP strength aluminum boxes, glass concrete, glass and PVB laminate panels, bamboo fiber, PET foam sandwich panels, ceramic composites, military helmet, storage tank, internal pipe explosion, water tanks, pressure vessel, blast protection walls, composite pipes, and many other engineering applications. One of the strongest features of this package is the incredible variety of the engineering material. Instead of repeating the same concrete and steel models, you'll work with a broad range of advanced material used in modern research and industry. This includes conventional reinforced concrete, UHPC, UHPC, FRC concrete, steel, aluminum, alloy, stainless steel, rock, soil, water, CFRP, GFRP, BFRP, AFRP, glare laminate, ceramic material, silica glass, glass epoxy composite, thermoplastic polyurethane, PET foam, metal foam, bamboo fiber, green composite material, rubberized concrete, glass concrete, PEEK, gelatin, concrete fill steel tube, masonries, and many more. Each workshop has been carefully prepared to provide a complete learning experience. For every tutorial, you'll receive the fully editable Abaqus CAE model, the ready-to-run input file, a detailed step-by-step video tutorial, material model codes whenever we need to write code to define the new material, research paper, and this means you can not only reproduce the published result, but also modify the models, perform your own parametric studies, and develop complete uh, new research project. Throughout the package, you'll learn professional techniques for modeling blast load, defining material behavior under high strain rate, implementing damage and failure models, create fluid structure interaction, interpreting shockwave propagation, evaluating structure performance, and analyzing damage mechanism. These are the same skill uh, you need. These are the same skills required for research publication, graduate thesis, consulting project, and industrial engineering application. Whether your interest is protective structure, military engineering, offshore platform, pipeline, bridge, tunnel, building, dams, pressure vessel, composite structure, and so on. This masterclass provides practical examples that can significantly accelerate your learning. More importantly, the package is designed so that every workshop builds your confidence in handling increasingly complex nonlinear dynamic analysis. By the time you complete all 65 workshops, you will have developed a deep understanding of the major explosion simulation techniques available in Abaqus and a valuable library of professional engineering models that you can adopt for your own work. If you're serious about mastering blast and explosion analysis in Abaqus, this is the training package you've been looking for. At the end of the package page here, we have payment information. The price is $197 for this exceptional package, include all the models of the explosion in Abaqus. We accept PayPal, Visa, Mastercard, and cryptocurrencies for the payment. Before payments, contact us through this email to tell you more about the package, the content, the payment method, and anything that you need to know. At the end, we put here the title of each example. At the end, you can see also the examples title here. For now, thank you for your attention.